I would like to further our discussion about the atomic spectral line. An emission line is formed when an electron makes a transition from a particular discrete energy level of an atom to a lower energy state, by which emitting a photon of a particular energy and particular wavelength. A spectrum, a continuous readout of emission lines, can be formed when many such photons show an emission spike at a wavelength associated with these photons. Conversely, an absorption line is formed when an electron makes a transition from a lower energy state to a higher discrete energy state, with a photon being absorbed in this process. The absorbed photons generally come from a background continuing radiation, and a spectrum will show a drop in the continuing radiation at the wavelength associated with the absorbed photon. These two states must be bound states, in which the electron is bound to an atom. So the transition is sometimes referred to as bound-bound transition, as opposed to a transition where the electron is ejected out of the atom completely, which is ionization. E2 minus E1 equal to Planck's constant times the frequency. Delta E equals h mu, which is Planck's law. A photon with energy equal to the energy difference between the levels is released or absorbed in this process. The frequency, mu, at which the spectral line occurs is related to the photon energy E by Planck's law, where h is Planck's constant, which is 6.626 times 10 to the minus 34 joules second.